Distance and displacement. Distance. Distance is the total path covered by the object in motion, irrespective of the direction of the path. It is a scalar measure of the spatial interval between two locations measured along the actual path connecting them, whereas displacement is defined as the total change in the object's position along with the direction of motion. It is a vector measure of the spatial interval between two locations measured along the shortest path connecting them. The unit of distance and displacement is meter, represented by m, and their dimension is L. Let's consider a curved path from point A to B. The actual path that is curved will be the distance, whereas the straight path will be displacement. So in this case, distance will be greater than displacement. But for a linear path, distance and displacement are equal. So it means that distance can be either equal to or greater than displacement, which implies that distance ratio displacement can be either equal to or greater than displacement. But it is not possible that distance is less than displacement. Let's consider a closed and circular path now. Here, distance will be equal to the circumference of the circle, or distance will be equal to 2 pi radius. But displacement will be equal to 0 because the initial point and the final point are the same, and no shortest distance can be measured between two same points. In this case, distance ratio displacement will be infinity because the denominator is 0, and anything divided by 0 is infinity. Now let's consider a semicircle. Distance will be circumference divided by 2, which is pi radius. And displacement will be the straight line between the endpoints of the semicircle, which equals to a diameter or 2 radii. So in this case, the ratio of distance to displacement will be pi radius divided by 2 radii, which equals pi by 2. Now let's consider 1/4 of a circle, which is a quarter. For this case, distance will be 2 pi multiplied with 1/4, which equals pi by 2 radius. For displacement, we observe that in the right-angled triangle, it is the hypotenuse. So we use Pythagoras' theorem to determine the displacement, which equals square root of radius squared plus radius squared. So displacement becomes square root of 2 radius. Now in this case, the ratio of distance to displacement equals pi by 2 divided by under root 2r. This becomes pi by 2 under root 2. You can calculate distance, displacement, and their ratio for a third, fourth part of a circle, and so on. Mention your answers in the comments. I will surely check them.